Hello students, today we are going to discuss about an angle made by a transversal with two or more lines, right? We can write it two or more lines also. So what do you mean by transversal? We will just firstly try to understand. If you see this particular definition I have written here, a line which intersect two or more given lines. Means suppose there are two lines, I don't know which type of nature they are having, but yes, there are two lines and there is a one third line which is intersecting both two lines. Then this particular line is called transversal, right? So it is a transversal of these two lines. Okay, suppose I am saying that suppose this is the one line, two lines, and there is one more line, and I am taking one more line here. Okay, so you can see that for these, this is L, this is M, this is N, and this is suppose P. So there are four lines. So what I will say that N is a transversal. N is a transversal for what L and M. Means this particular line N is a transversal for line L and M, right? Now if I say what is the P, what is P here? P is again a transversal, right, for L and M, absolutely. Now suppose I am saying if you just forget this one for a while, can you see this one? Okay, sorry, I am drawing this one again and this one I am removing. So now you will say that M is a transversal for these two lines, right? So we will say that M is also a transversal for P and N. So it means transversal, you have to understand this particular term very clearly, that any line which is intersecting two or more lines, any line in any direction is not required, then we will say that that particular line will be known as transversal. And what is the unique thing of a transversal? Transversal actually forms angles on each line. If you see, this particular transversal is making angle at this point and at this point. There are four angles which are actually forming, right? And we will discuss about these angles in this particular topic. This is the main important point. Now we will try to just understand, because it is related to the pairing, right? Like for example, you have discussed about linear, you have discussed about vertically opposite angles, right? So what we were doing there, we were trying to join two angles, or we are trying to make a group complementary angles, right? Supplementary angles. So in that particular topic also, we are trying to define two angles and we are trying to build up a relation between them. So here also we will try to build up the relation between two angles, like what is the connectivity, and then we will give the name. This is the chapter, or this is the topic, right? Now I am coming to the next point. Now students, I have drawn two figures here, figure 1 and figure 2. If you see, this is the figure 1 and this is figure 2. In first figure and second figure, if you see, one transversal is there for these two lines. But what I will do, in the first figure, I will take only the interior angles. Interior angles means which are actually interior of these two lines, right? So suppose I am taking this angle, this angle, this angle, and this angle. Clear? Okay. For these, this is called exterior angles. First of all, we have to understand which one is interior and which one is exterior. So these angles are called interior angles. And these angles are called exterior angles. Right? Now I am coming to the point. Suppose I am saying, like for example, I am taking all the angles down here. So one by one we will discuss. I am giving a name now. 1, 2, 3, 4. This is 5, 6, 7 and 8. So how many angles are here? 8. 8 angles I have seen, and we will try to build up which angle will be similar or will make a relation with the other angle. So we have to check on this particular point. So if you see this angle 1, I am coming one by one. I am coming one by one here. If you see angle 1 is on the upper side of the line. If you see, it is just above this line. So where is which angle in this particular line which is above the line and on the right side? Are you getting my point? Which angle is above the line and on the right side? So definitely it is angle 5 because it is above the line and on the right side. It is also in the same direction. So actually what we will do here, we are following the directions part. We are seeing the directions. We are seeing some other things also. In this case we are talking about direction. So we will say that angle 1 and angle 5, right, are in the same direction, and in this case angle 2 and angle 6 are in the same direction. Now some student can say that sir, angle 4 and angle 8 are also in the same direction, right, and angle 3 and angle 7 are also in the same direction, right. So what we call these type of groups, what is the name? So the name of for these groups is what? Corresponding angles. These groups are called corresponding angles, where we are seeing the directions. I am just writing for roughly idea so that you can understand directions. On the basis of directions, we have decided 4 pairs, right, which are actually behaving like a corresponding angles. Now I am coming to the next point. Okay, now I think it is known part which I will discuss. Angle 1 and angle 3. Angle 1 and angle 3. Angle 2 and angle 4. Angle 2 and angle 4. Angle 5 and angle 6. Sorry, angle 7. Now angle 6 and angle 8. So which type of angles are these? These are called vertically opposite angles, right, and we know that vertically opposite angles are always equal. So 4 pairs for vertically opposite angles, right. Now I am coming to the next one. If you see this one, angle 4 is interior, angle 5 is in the interior and on the same side, right. Angle 4 is and 5 in the interior and on the same side. So we will say that angle 4 and angle 5, angle 3 and angle 6. We call it co-interior angle. Co-interior means co word we are using here also. Corresponding is say we have to check each and every direction. But in this case we are just checking co but in the interior. Direction we have to check where is the direction, but it should be in the interior. In this case we will check the direction and we will check the position also. Corresponding, this is the meaning of this corresponding word, because we will check the position also. Okay, now suppose I am seeing that angle 1 and angle 8, angle 1 and angle 8, so they are just outside of these two lines. It means they are in exterior. And angle 2 and angle 7, what they are called? Co-exterior angles, right. Names are very easy, simple grouping. Now I am coming to this one. If I say angle 4 and angle 6, what is the name of this group? This is on different side, this is on different side, but they are in interior. That is correct. One thing is matching. So angle 4, if I say angle 6, if I say angle 3 and angle 5, so we will say that alternate. Alternate means they are actually in different directions, right. Alternate interior, but in the interior, right. Now I am coming to the next one. Angle 1 and angle 7 and angle 2 and angle 8. These are alternate, right, but exterior angles. So before entering in transversal, before entering in the in this particular topic, we should understand the meaning of vertically opposite angles. We should understand the meaning of corresponding angles, linear pairs, because everything will be included here. If you see this one, angle 1 and angle 2, what they are? They are linear pair. If I just try to connect with the previous knowledge. So angle 1 and angle 2, angle 3 and angle 4. Some student can say that sir, angle 2 and angle 3, angle 1 and angle 4, angle 5 and angle 6, means they are actually forming a linear pairs also. So it means previous knowledge also works for these 8 angles, previous connectivity, previous grouping. So this is about the angle made by a transversal with two lines. Now I am coming to the next step. What is the next step of this? This is the one concept and which we will apply for a particular condition. What is that condition? We will try to understand. Now students, you can see I have made a very unique figure, but in this unique figure what I have done, you can see that L and M I have drawn a parallel line. In the previous figure we were not discussing about these two lines, that they are parallel or not, but in this case we are just assuming that if these two lines are parallel and there is a one transversal is passing, then what will happen with those groups? Is there any change? So what are those changes? We will just try to understand. If I just try to recall again, we have given this name is angle 1, this is angle 2, this is angle 3, this is angle 4, 5, 6, 7 and 8. Again I am repeating corresponding angles. If I see from this figure, so you will see that angle 1 is on the above this line and on the right side, and here angle 5 is above the line and on the right side. So we will say that angle 1 and angle 5 are corresponding, angle 4 and angle 8 are corresponding, angle 2 and angle 6 are corresponding, and angle 3 and angle 7 are corresponding. So what happens when lines are parallel? Right, if lines are parallel, then I want to tell you corresponding angles, right? Corresponding angles are equal. Corresponding angles are always equal. I will use always word because it is true for all, right? So it means if I just want to write in terms of angles, so I will say that angle 1 will be equal to angle 5, because angle 1 and angle 5 are corresponding angle. Now angle 4 is equal to angle 8. In this case angle 2 will be equal to angle 6, right? If you know, you have understood the corresponding angle group of corresponding angle, then you have to put here equal between them, and angle 3 will be equal to angle 7. This is very important axioms. Sometimes we call it axiom because we cannot prove it. It is mandatory to understand, or we have to be very specific that it is true always. We cannot prove. Axioms are those statements which cannot be proved. They are the universal statement, universal truth, right? Now alternate interior angles. Can you tell me alternate interior angles? If you just see alternate, I have told you different directions, but in the interior, different directions but in the interior. So definitely 4 and 6 and 3 and 5, there are two groups, and for exterior it will be 1 and 7 and 2 and 8. So alternate exterior angles and interior angles. What will happen if the lines are parallel? Definitely they are also equal, always, right? It is also always. It is again alternate interior axioms or exterior angle axioms. Now I am coming here. Angle 4 will be equal to angle 6, and angle 3 will be equal to angle 5, and angle 1 will be equal to angle 7, and angle 2 will be equal to angle 8, right? You have to accept all these conditions in any case, but you have to be very specific. These two lines should be parallel and one transversal should be there. If these lines are not parallel, then you will not say that they are equal. This is only for parallel line and a transversal, right? Angle made by a transversal with parallel line. Now the concept I have changed with parallel lines. Now co-interior angles and co-exterior angles. If I say co-interior and co-interior I have told you co means on the same direction, okay, 4 and 5, 1 and 8, but interior. So definitely we have to approach 4 and 5. So co-anterior angles and co-exterior angle are equal? No, they are always supplementary angles. Are supplementary angles, and you know that the meaning of supplementary means the sum of these two angles will be what? 180 degree. What will be the value of angle 3 and angle 6? Because they are also comes in the category of co-interior. Angle 2 and angle 7 comes in co-exterior because in the same direction but in the exterior. So it will be angle 2 plus angle 7 is equal to 180 degree. Then angle 1 and angle 8 is equal to 180 degree. So this is very important axioms for higher classes also. We always use, right? So class, please try to make it again in your own, make your own figure and try to write it again and again. At least 2 or 3 times you should write, then you will be able to understand the meaning or all corresponding angles and alternate interior angles, co-interior angles, because that mapping is very very important, right? Now students, we will try to solve one very interesting question. In this particular parallel lines and transversal case, if only one angle is given, then we can find all the other 7 angles easily. How? Okay, one by one we will try to understand. Just only by in the figure, it is suppose 65 degree, so you can understand what is the corresponding part of this. Definitely this one. So it will be 65 degree. Reason, corresponding angles are equal. Now, and you know that if this is 65, then this will be 65. Reason is vertically opposite angles are always equal. Now, if you know this one 65, so can you see this one? This will be 65. Reason, corresponding angle. Just see below the line, and on the same direction. Now you can see that this 65 and 65, they are co-interior angles, and you know that co-interior angles, the meaning of co-interior angles. Oh sorry, alternate interior angles, not co-interior. It's a alternate interior angles. And if suppose I want to find this angle, so there are two approach. One is we can use this angle and this angle by using linear pairs, or we can use this angle and this angle. Suppose this is x and this is 65, and we know that x plus 65 is equal to what? 180. Reason, we know that co-interior angle. So I have already told you, co means generally it is related to conjugative. We call it conjugative interior angle because it is the conjugative of this one is this. But sometimes for better understanding you can understand in the same direction but in the interior. That is the better way to understand. Now it will be 180 minus 65, then it will be 115 degree. So we have this one 115 degree. If this is 115 degree, then this will be 115 degree. If this is 115 degree, okay, you can take this is 115 degree because alternate interior, or you can make a corresponding angle also. And this is 115, then this is 115. It means by only by taking one angle, we can find the other 7 angles easily by using axioms, corresponding angle axioms, right? Alternate interior angle property, right? And co-interior property. So there are so many questions related to this particular conditions. Now I am taking one more question here. If you see, there are this is a parallel line, and there is one more figure is given, and suppose this is 50 degree, and this one is suppose 130 degree, and the question is you have to prove that this line is parallel. Okay, we don't know the lines are parallel or not, but these two angles are given. Okay, one thing is also I want to explain. This particular conditions we have found when these two lines are parallel, corresponding angles are equal, alternate interior angles are equal. If we just do the reverse of this, reverse means if we are having one pair of lines, where corresponding angles are equal, alternate angles are equal, so we can say that lines will be parallel in that case. Because if corresponding angles are equal and alternate interior angles are equal, it means the lines were parallel. That is why they are equal. So we can use the reverse, vice versa of this one. If corresponding, you can see that if this is 130, right? So it will be 50 degree by linear pair. And now you can see that these two angles are equal. And what are the name of these two angles? Corresponding angles. It means it proves that corresponding angles are equal. So what is the condition when the corresponding angles are equal? When these two lines are parallel. So we can say that L will be parallel to M. It proves that because lines can be parallel only and only in one condition, when corresponding angles are equal, or alternate interior angles are equal, or sum of co-interior angles is 180 degree. Means if any three condition in one out of these three conditions we found, then we can say that lines are parallel. It means this particular process we can use in a reverse direction also, right? So this was the introduction of lines and parallel lines and transversal, and I think you can do other sums also. Thank you so much for watching this video.